In this video, I'll be going over how to use the power rule for derivatives. So let's start off with a question. Let's say we're given f of x equals x to the power of 3. How do we differentiate something like this? So here's the formula for these types of questions. F of x equals x to the power of n. And the derivative of that, x prime of x, equals n times x to the power of n minus 1. And n is a constant. Now we know the formula, let's work with the question so we can have n as a number. So in order to differentiate x to the power of 3, we need to identify our n value. In this case, our n value is 3. So we can differentiate it out like this. So f prime of x equals n times x to the power of n minus 1. So n is 3 times x to the power of 3 minus 1. So f prime of x is simply 3x to the power of 2. And this is the derivative of x to the power of 3. Now, let's do some more practice examples so you can get the hang of it. Let's find the derivative of x to the power of 6. So how would we do something like that? So we can identify our n value as 6. And knowing the formula, f prime of x equals nx to the power of n minus 1, we can just substitute 6 into n. So our answer would be f prime of x equals 6 times x to the power of 6 minus 1, which is f of prime of x equals 6x to the power of 5. And this would be our derivative. Now, let's try two more examples. Find the derivative of x to the power of 7 and the derivative of x to the power of 100. So feel free to pause this video and work on it by yourself. So for our first question, our n value is 7. So we could write out our answer like this. 7 times x to the power of 7 minus 1, which is 6. And that is our answer for our first question. For our second question, our n value is 100. So we'll have 100 times x to the power of 100 minus 1, which is 99. And that is our derivative for x to the power of 100. Now, here's something you should try and memorize. Let's say we want to find the derivative of x. So in this case, our n value is just 1. So let's try using the formula n times x to the power of n minus 1. So let's substitute 1 into n. So when we do this, we get 1 times x to the power of 1 minus 1. And what that really is 1 times x to the power of 0. And x to the power of 0 is simply 1. So we get 1 times 1, which is simply 1. And this is our derivative of just x. So when your exponent value is 1, your derivative will always have the value of the coefficient. Now, let's go over a simple rule on how to get the derivative of a constant. The simple answer to this is the derivative of any constant is simply 0. Here's an explanation using the power rule. So let's find the derivative of 6. So 6 is equal to 6 times x to the power of 0. So let's use 6x to the power of 0 for this demonstration. So let's find the derivative of 6x to the power of 0. So our n value in this case would be 0 right here. And so we can write it out like this. 6 times 0 times x to the power of 0 minus 1. So since there's a 0 here, this will turn everything here into 0. So this is why the derivative of any constant is equal to 0. Let's move on to a different type of problem. Let's say we want to differentiate something like this. Find the derivative of 3x to the power of 3. So in this case, our n value is 3. So we can write it out like this. 3 times 3 times x to the power of 3 minus 1, which is 9x to the power of 2. And 9x to the power of 2 is the derivative of 3x to the power of 3. So try the next two questions. Find the derivative of 4x to the power of 5. And find the derivative of 9x to the power of 8. Feel free to pause the video and work on this by yourself. So the derivative of 4x to the power of 5, our n value is 5. So we can write it out like this. 4 times 5 times x to the power of 5 minus 1. And then simplify this. 4 times 5 is simply 20. X to the power of 5 minus 1 is 4. So our answer is 20 x to the power of 4. For the second one, our n value is 8. So let's rewrite this. 9 times 8, x to the power of 8 minus 1, simplifies to 72 x to the power of 8 minus 1, which is 7. So we're left with 72 x to the power of 7 as our derivative for 9x to the power of 8. So try these two questions. Let's say we want to differentiate 9x and we want to differentiate something like 5. So let's do the first question. What's the derivative of 9x? So our simple answer here is just 9. And the math behind this is since our n value is 1, what we're really doing here is 9 times 1 times x to the power of 1 minus 1. So it's 9 times 1 times 1, basically. So our answer is just 9. So for the second one, what's the derivative of 5? So the derivative of any constant is 0. And that is our answer for this question. Okay, so now that you know the very basics, let's try some harder questions. Find the derivative of 4x to the power of 4 plus 2x to the power of 3. So our n value for 4x is 4, and our n value for 2x is 3. So we can rewrite it like this. 4 times 4 x to the power of 4 minus 1 plus 2 times 3 x to the power of 3 minus 1. And then 4 times 4 is simply 16, and x to the power of 4 minus 1 is x to the power of 3. And 2 times 3 is 6, and x to the power of 3 minus 1 is x to the power of 2. And this would be our answer. Let's try another question. Find the derivative of 6x to the power of 5 minus 3x to the power of 3 plus 2x. So our n value for 6x is 5, n value for 3x is 3, and here would just be 1. So we can rewrite it out like this. 6 times our n value, 5, times x to the power of 5 minus 1 minus 3 times 3 times x to the power of 3 minus 1 plus 2 times 1 times x to the power of 1 minus 1. So, for the first part, 6 times 5 is 30, and x to the power of 5 minus 1 is x to the power of 4. For the second part, negative 3 times 3 is negative 9, and x to the power of 3 minus 1 is 2, x to the power of 2. And for the third part, 2 times 1 is 2, and x to the power of 1 minus 1 is 0. So that simply just is basically 1. So this would be our final answer. Let's try one last question. Find the derivative of 7x to the power of 9 minus x to the power of 6 plus 3x plus 5. So our n value for here would be 9, 6, 1, and 0 basically. So let's simplify this out. 7 times 9, x to the power of 9 minus 1 minus 6 times x to the power of 6 minus 1 plus 3 times 1 x to the power of 1 minus 1 and 5 times 0. So 7 times 9 is 63, and x to the power of 9 minus 1 is x to the power of 8. Negative 6 times x here, and x to the power of 6 minus 1 is simply 5, and 3 times 1 is 3. X to the power of 1 minus 1 is simply 0, so then x to the power of 0 is just 1, so we don't need to write anything down there, plus 5 times 0, which is just 0. So this right here would be our final answer. Now we will be finding the derivatives of fractions. Let's start off with something easy for an example. Let's say we want to find the derivative of 1 over x squared. So how would we do something like this? So for this, we want to bring the x squared to the numerator. So when we do that, we could rewrite this out as x to the power of negative 2, since that's the same thing as 1 over x squared. So our n value here is negative 2. So we could rewrite this as negative 2 times x to the power of negative 2 minus 1. So what we get here is negative 2x to the power of negative 3. So now we want to bring x to the power of negative 3 back to the denominator. So we get negative 2 over x to the power of positive 3. And that is our final answer. Let's try a few more practice examples. Let's find the derivative of 1 over x to the power of 5. So our first step, let's move x to the power of 5 up to the numerator. So we get x to the power of negative 5. Now we can derive it from here. Our n value is negative 5. So we'll have negative 5 times x to the power of negative 5 minus 1. And so we get negative 5x to the power of negative 5 minus 1, which is negative 6. So now we can bring x to the power of negative 6 down to the denominator. So we'll have negative 5 over x to the power of positive 6. And this is our answer. Let's try another question. Find the derivative of 1 over x to the power of 7. So our first step, let's bring x to the power of 7 up to the numerator. So what we get is x to the power of negative 7. And since our n value is now negative 7, we can differentiate this. So we get negative 7 times x to the power of negative 7 minus 1. Negative 7x to the power of negative 7 minus 1 is negative 7x to the power of negative 8. Now, let's bring x to the bottom. So we get negative 7 over x to the power of 8. And that is our answer. Let's try another example now. Find the derivative of 4 over x to the 5. So you want to see this as 4 times x to the negative 5. So this is the same as that. So now our n value here is negative 5. So let's rewrite this. So we have 4 times our n value, which is negative 5, times x to the power of 5, negative 5, minus 1. So let's simplify this. 4 times negative 5 is negative 20. X to the power of negative 5 minus 1 is x to the power of negative 6. So now let's move the x to the power of negative 6 to the denominator. So what we get here is negative 20 over x to the power of 6. And this is our answer. Okay, so let's move on to finding the derivative of radical functions. So here's an example. Let's say we want to find the derivative of the square root of x. The square root of x can be written as x to the power of 1/2. So let's work with this one right here. So x to the power of 1/2, our n value is simply 1/2. So we could rewrite it out like this. 1/2 times x to the power of 1/2 minus 1, which is also 2 over 2. So 1/2 x to the power of 1/2 minus 2 over 2 is simply x to the power of negative 1/2. So let's bring x to the denominator now. So we can rewrite this as 1 over 2 x to the power of 1/2. So that's the same as 1 over 2 times the square root of x. So let's rationalize the denominator. So we can times the square root of x into the numerator and the denominator. So what we get is the square root of x over 2x. And this would be our final answer. Let's try another question. Let's say we want to find the derivative of the fifth root of x to the power of 6. So the fifth root of x to the power of 6 can also be written out as x to the power of 6 over 5. And in this case, our n value is 6 over 5. So we can write it out like this. N times x, so 6 over 5 times x to the power of n minus 1. So 6 over 5 minus 1, which is basically 5 over 5. So we're left with 6 over 5 times x to the power of 1 over 5, which can be written out as 6 times the fifth root of x over 5. And this is our final answer. So let's do one more radical example. Let's say we want to differentiate the eighth root of x to the 7. So we could write this as x to the 7 over 8. So now our n value is 7 over 8. So we could write it as 7 over 8 times x to the power of 7 over 8 minus 1, which is 8 over 8. Now we can simplify this down. 7 over 8 times x to the power of 7 over 8 minus 8 over 8 is x to the power of negative 1 over 8. So let's bring x to the power of negative 1 over 8 to the denominator. So then we'll get 7 over 8 times x to the power of 1 over 8. So we could rewrite this as 7 over 8 to the 8th root of x. And if we rationalize this, we'll get 7 times the 8th root of x to the 7 over 8 times x. And this is our final answer. Now, let's review and apply these concepts that we have just learned. I'm going to apply these concepts into a few questions. So let's say we want to find the derivative of negative 9 times x to the power of 100. So in this case, our n value is 100. So we can write this out as 9 times 100 times x to the power of 100 minus 1. So we can simplify this out. So we'll have 900 times x to the power of 100 minus 1, which is 99. And this is our answer. On to our second question. Let's find the derivative of 9x to the power of 5 minus 3 over 4 x to the third plus 12x plus 2. So our n value for 9x to the fifth is 5. So we could write it out as 9 times 5 times x to the power of 5 minus 1. For negative 3 over 4 x to the power of 3, we can write it out as 3 over 4 times 3 times x to the power of 3 minus 1. For 12x, our n value is simply 1. So for this, as we learned earlier in this video, 12x to the power of 1, the derivative is simply 12. For 2, any constant, the derivative will always be 0. So we just have 0. So let's simplify this down. 9 times 5 is 45. And x to the power of 5 minus 1 is 4. Negative 3 over 4 times 3 is negative 9 over 4. And x to the power of 3 minus 1 is x to the power of 2. And then we have plus 12 here. So this is our final answer. On to the third question. So for the third question, we'll have 4x to the fifth plus 5 over x to the fourth plus the third root of x squared. So our n value for 4x to the fifth is 5. So we can write this out as 4 times 5 times x to the power of 5 minus 1. For the second part, 5 over x to the fourth, we need to bring the x to the fourth up to the numerator. So we'll have 5 times x to the negative 4. For the third part, the third root of x squared, we can write this out as x to the power of 2 over 3. So now let's simplify this down. 4 times 5 is 20, and x to the power of 5 minus 1 is x to the power of 4. So for the fraction one, what we want to do here is identify our n value. Our n value is negative 4. So we'll have 5 times negative 4 times x to the power of negative 4 minus 1. For the radical one, our n value is 2 over 3. So we can write it out as plus 2 over 3 times x to the power of 2 over 3 minus 1, which is the same as 2 over 3 minus 3 over 3. Let's simplify this down. So, positive 5 times negative 4 is negative 20, and x to the power of negative 4 minus 1 is x to the power of negative 5. So onto the radical, we have 2 over 3 times x to the power of 2 over 3 minus 3 over 3, which is x to the power of negative 1 over 3. So for negative 20 x to the negative fifth, we can write this out as negative 20 over x to the power of positive 5. And for the radical, let's bring the x into the denominator as well. So we'll have 2 over 3 x to the power of 1/3. For the radical, if we rationalize this, we can write it out as 2 to the third root of x to the power of 2 over 3x. So our final answer is 20 x to the fourth minus 20 over x to the fifth plus 2 to the third root of x squared over 3x. And this is our final answer. So for our last question, let's derive the third root of x times 2x squared plus the fifth root of x. So for our first step, we want to change all of these into exponent form. So the third root of x is simply x to the power of 1 over 3, and 2x squared can be left the way it is. And the fifth root of x could be simplified down to x to the power of 1 over 5. Now, let's distribute these terms. So x to the power of 1/3 times 2x squared is simply 2x to the power of 7 over 3, since we add the exponents. And x to the 1/3 times x to the 1/5 is x to the 8 over 15. So now, our n values are 7 over 3 and 8 over 15. So let's work with those. So we'll have 2 times 7 over 3 times x to the power of 7 over 3 minus 1, which is basically 3 over 3. And for the second term, we'll have 8 over 15 times x to the power of 8 over 15 minus 1, which is the same as 15 minus 15. Let's simplify this now. So we'll have 14 over 3 x to the power of 7 over 3 minus 3 over 3, which is x to the 4 over 3. For the second term, we'll have 8 over 15 x to the power of 8 over 15 minus 15 over 15 is simply negative 7 over 15. So now, let's make this look nicer. So for our first term, we'll have 14 to the third root of x to the fourth over 3. And for the second term, we need to bring the x to the negative 7 over 15 into the denominator. So we'll have 8 over 15 x to the 7 over 15. So now, let's just work with our second term here so we have space. So we'll have 8 over 15 15th root of x to the 7. And when we rationalize this, we'll have 8 to the 15th root of x to the 8 over 15x. So our final answer is 14 times the third root of x to the fourth over 3 plus 8 times the 15th root of x to the 8 over 15x. And that is our final answer.